Okay, well, it's 10 o'clock, so we'll get started. Hello, everyone. Thank you for joining us today. My name is Linda Herman. I'm the Client Relations Manager for Imaging Biometrics. Today's webinar, titled Integrating IB Clinic and Routine Clinical Workflows, focuses on the use and clinical application of IB software. It's being presented by Josh McCormack, Senior Software Engineer for Imaging Biometrics. And we have muted the microphones, but we encourage you to use the chat feature to ask questions. And today's webinar is also being recorded. It will be made available on our website at www.imagingbiometrics.com. And so I'll turn it over to you, Josh.
All right. Thanks, Linda. Yeah, my name is Josh. I actually recently was promoted to Director of Software Engineering, so that's exciting news. So before we get into the technical weeds on how we actually integrate our software, Tim, our CTO, is going to give a quick background on what some of the output is and how it's useful, and then we'll dive into those weeds.
Sounds good. Thanks, Josh. Want to flip up? Here we go. We'll go through some background and information about the IB Clinic software itself. Real quickly, I know we have a wide mix of attendees here, some of whom are not familiar with some of the stuff we put out. So just to give everybody a little bit of background, IB was formed just over 15 years ago in response to the question, who does DSC perfusion the best? The question came up at Medical College of Wisconsin, and so they did a study and determined that the leakage correction method used in IB Neuro was actually the most reliable and most accurate mechanism. Subsequently, another technology also included in IB Neuro called dual echo is also has similar results to the leakage correction method in IB Neuro. And so IB was formed. Our flagship product, IB Neuro, was written and FDA cleared at the beginning of 2008. At the time, it was designed as a plugin for the Osirix platform. There were a variety of reasons why that happened, why that was done. It was an excellent choice at the time. But what we found is that, we created 5 different plugins: IB Neuro, we mentioned, IB Diffusion, IB DCE, IB Delta Suite, and IB RadTech were all initially developed on that platform. Josh, you want to go ahead? In 2017, though, taking advantage of some newer technology, we created standalone executable versions of all of our core IB algorithm applications and containerized them. And I don't want to steal too much of Josh's thunder. That's what he's going to be talking about shortly. But some of the advantages of doing that is that it became a platform independent tool, no longer locked into the Mac like the Osirix platform is. We remain vendor neutral. We'll process anybody's images. We create standard DICOM output. Everything we're doing is still FDA cleared. And perhaps the biggest benefit now is that all of our clinic tools are fully automated. They can be sent directly to IB Clinic from the scanner. They are processed without manual intervention and sent to the PACS for the neuroradiologists and others to interpret. Our IB Clinic software sits on your network just as a regular DICOM node. All of the data processing is done within the organization's firewall. There's no data that has to leave your network. And next slide, Josh. So just a real quick overview of the applications that we have containerized. The first is our flagship IB Neuro. As mentioned, it has the most proven, the most accurate contrast leakage correction. And it really helps answer the question, what's going on with this area of enhancement? So it's used for everything from initial diagnosis to ongoing treatment monitoring. We remain the only DSC MRI platform that provides actual quantitative data, allowing you to assess RCBP values in both fixed images and over time, comparing them across patients, across scanners, and so on. It's been independently validated with tissue samples. It can be performed or processed data using, or data acquired using less gadolinium, and it remains consistent with the national standard consensus acquisition protocol released a couple of years ago. Next slide. In addition to IB Neuro, our next product is the IB Delta T1 maps. And this really helps with what I would call standard of care interpretation. Pre and post contrast T1s. You've got samples on the screen here. The question is, what is the true enhancement? Studies have shown that expert readers can disagree over half the time. It takes a lot of time to make that assessment. In tumor board, it can resolve some arguments. The Delta T1 map you see there in red and blue really does help address that question. What is the true enhancement? The red regions that pop out, even a non-radiologist like yours truly can tell at a glance what those enhancing regions are. Next slide, Josh. We have two other products, two other plugins that are full body that are also available in IB Clinic. The first is IBDCE, which uses dynamic contrast enhanced perfusion analysis. As noted, this is available throughout the body. It's used typically in neuro and spine applications, but is also applicable in prostate and breast. It, like IB Neuro, performs perfusion analysis, but is really typically more used in permeability analysis type applications. Again, is fully automated and is available in IB Clinic. Next slide, please, Josh. And finally, we have IB Diffusion, again, a whole body application. We mentioned ADC on this slide, but we also have 3 or 4 other diffusion methods, diffusion computations that can be used to help assess various biomarkers, again, throughout the body. So again, recapping, IB Neuro is our flagship, DSC perfusion. We also have IBDCE and IB diffusion, and finally, IB Delta T1s. With that, I'm going to turn things back over to Josh and let him talk about the actual implementation and integration of those tools.
Perfect. Thanks a bunch, Tim. So every use case is kind of different. If we're deploying IB Clinic, we're going to get details about your specific case setup. And but for this presentation, I'll talk about our primary deployment scenario. However, at any time, please interject with any questions and we can talk about specific use cases. So Tim and Linda, if you guys can just keep an eye on those questions and shout them out whenever they come up, that would be a great help. So the primary deployment method is we actually will host IB Clinic in a Docker or Podman container as a continuous running server on a host machine. And it'll exist as a DICOM node on your local network. Now, there's an additional optional input mode, which can just read in DICOM files from a directory. So this can provide additional flexibility for integrating with your own custom scripts or workflows or pipelines. But again, the primary deployment method we do is typically a DICOM node that's continuously running. So I don't know, can you guys see my mouse on the screen here? It may or may not be visible. You can, okay. So first and foremost, like all input is transient in the IB Clinic server. So we recommend when transferring data, you want to send all the source data from your scanners, from your source, to your PACS immediately for backup. Now, then you can also send the input data to the IB Clinic server at the same time. The IB Clinic server will accept the input, generate the output, the parameter maps based on your specific configuration, and then send those over the network back out to your PACS for storage. From there, of course, you can query and take a look at that from your PACS workstation. So all output settings are configurable, such as what maps we want to look at, that Tim went over, RCBVs, Delta T1s, etc. And then individual map settings. For instance, we can adjust the pixel resolution or perhaps scale up the pixel values themselves for taking measurements. So IB Clinic has automated input identification for the different types of inputs. So DSC, DCE, diffusion, and then T1 weighted pre and post contrast series. We have a set of default rules that typically works in most cases for input identification, but since different acquisition protocols can vary, they don't apply in every case. So we added customizable rules for input identification. So for instance, a common approach that we use is when we are generating a delta T1, we require a pre and post contrast T1 weighted series. In order to identify a matching T1 weighted series between the pre and post contrast, in our default rules, we make some assumptions. For instance, we would naturally assume that the post contrast would be acquired after the pre, or the pre contrast, of course. But because we might be filtering out a lot of additional input, such as additional T1 weighted series, we have additional scrutiny for matching up those inputs, such as applying the same number of, assuming that they have the same number of slices or images within that series. But that's not necessarily a requirement for generating a delta T1, and depending on the acquisition protocol, that may not be the case. So a common custom rules approach that we use is if there are a naming convention and series description, we'll use the series description DICOM tag in order to identify those inputs. So, and we can create these rules to still be pretty flexible. So for instance, even if you're using a consistent naming convention for your pre and post contrast series, we can account for some variability. For instance, you might have different names for a post contrast, such as an axial T1 plus C or a post axial T1. So in this case, both of these could be a post contrast series that we would want to use for delta T1 generation. So in the case of RCBVs, we require a DSC series as input to generate those. However, we can also optionally configure this to overlay that output over a reference map. And by default, this is going to be a post-contrast T1 series, and we typically just grab the latest post-contrast series to overlay that. However, that may not be applicable in every case. For instance, some clients prefer to overlay it over a specific series that they've identified, and they might name it reference T1, for instance. So those are some of the use cases that we apply the customizable for. But let's take a look at what this actually looks like. So I have an IB Clinic server running currently on our local network, and then I'm going to use this DICOM viewer to essentially simulate the PACS or scanner that would be sending to IB Clinic in this case. There's two, of course, this is all automated processing happening in the background, so there's not a lot to look at. But if you're, say, an IT technician, you may be monitoring some of the logs in IB Clinic, which would all be output just to a logs directory. The two primary logs that we'd be monitoring is the store SCP log, and this is what is tracking all the network traffic when we're sending data to IB Clinic as a DICOM node over the network. So this wouldn't be applicable in, say, the directory input approach if you're using custom scripts in your pipeline. And then the other important log is, of course, the process.log. So this is where we output all of our processing messages for successful or perhaps failed scenarios where potentially all the input did not arrive, for instance. And then we also have specific execution logs, which this is a case-by-case log. So for any given processing attempt on a module, we will output additional information in these time-stamped logs here. So in this case, I'm actually outputting all the store SCP output in this top console. In the bottom console, I have the processing log. So we can just send some of this input data. So I have a perfusion series, DSC, and a pre and post contrast T1 series that I'll be sending to IB Clinic. So you can see while the transfer is in progress, we got a lot of activity in the store SCP log. And this is outputting a file by file DICOM series transfer. So after the transfer is complete, we have a timeout set. So we will wait for additional input based on a configurable amount of time. For this demo, I just set it to 10 seconds. So after the transfer was complete, IB Clinic waits 10 seconds before attempting to process in case additional data is going to come over the network. And it already processed the Delta T1 and IB Neuro data. We can see that Delta T1 already came back to us, as well as the IB Neuro output, which in this case is the RCBV maps. So currently I have this configured to output both the RGB and grayscale or quantitative outputs for Delta T1 and RGB and grayscale RCBVs. Now there's additional output as well for quality assurance, such as we have AIF curve output. So we can take a look at this to make sure that the injection or bolus was applied correctly. So we should see a nice spike after the given baseline, which is here in this gray area. And we also have AIF points, which can be output to show which individual voxels were selected for generating the AIF curve. And then Delta T1 also automatically performs co-registration between the T1 pre and post contrast series. So for quality assurance purposes, we also output the registered pre and post contrast series to make sure that looks okay. Right. So by default, we will, as I mentioned before, we'll overlay a perfusion series over a T1 series as a background anatomic. That's what we have right now. A common issue that we might actually encounter is a client might see, hey, my RCBV, the actual map looks correct, but the background is wrong. And that is often because it is overlaid on the wrong image. So if it doesn't find a T1 image in order to overlay, it will just default to the perfusion series itself. This is often because of a transfer timeout. So for instance, if our transfer timeout where it's waiting for input data is too short, or the network is just really bogged down, it's possible that all the data did not arrive in time and it would begin processing prematurely. So typically, we would set the timeout to at least 30 seconds, but depending on your network and bandwidth speeds, you may want to increase this time. Of course, if this is a continuous running server, every now and then the server itself may go down, as in the host machine, but we will configure IB Clinic to come back up with the server and automatically start if we're running in that configuration. Another scenario is if we're deploying custom rules, our rules just may be inadequate. So for instance, we'll survey to see what your naming conventions are, if that's the approach we're going to use, but we may fall short. So for instance, we may not be aware of that we're going to name some of the post contrast T1 series differently from the original one. For instance, we may be just expecting the actual T1 plus C and not be aware of the post axial T1. So that's another common issue that we may encounter, but those are quickly and easily resolved over time. Some requirements. So again, as Tim mentioned, this can it's platform independent. We can deploy on Windows, Mac OS, or Linux. We recommend Linux. It's really easy to say spin up a headless server if this is going to be running as a continuously running server in the background. If you can have like a dedicated virtual machine, for instance, where IB Clinic doesn't have to be competing for resources with other applications, that's ideal. And that's where, some of these minimum requirements, such as only 4 gigs of RAM or 2 CPUs, really come into play. However, if this is running on like a desktop, a Windows desktop, for instance, you're really going to need a beefier machine in order to account for the additional programs that may be running on that host machine. So some future features. One, if you are working with us to, say, integrate IB Clinic into your specific platform, right, currently we deploy this as a single container, but we're actually going to take a multi-container approach or architecture, which in order to leverage things like Podman pods, Kubernetes, or Docker Compose, if you're deploying this with Docker. And what that does is it allows additional scaling. So we plan to implement asynchronous processing so that we can do some horizontal scaling. So you could have a single IB Clinic server running one instance that will be able to process multiple inputs at the same time. Of course, if we're doing horizontal scaling, then those requirements for the host machine would, of course, need to be increased in that case. But by also leveraging the multi-container approach and integrating with Kubernetes, we would open up the possibility for horizontal or vertical scaling as well. So just deploying more instances. Some new features we are working on is longitudinal reporting. So for instance, looking at multiple delta T1s over time for a specific patient. Right now, we just output reports for an individual instance, but we are going to add the ability to be able to query the PACS for historical data on that given patient and then output longitudinal reports as well. We also have added a flexible workflow defined processing. So we can essentially easily code up a different processing approach for your specific use case. So for instance, maybe you want IB Clinic to forward the inputs to another location for additional processing. That's going to be possible with this flexible workflow approach. And then also leveraging that, we are going to enable automated FTBs or fractional tumor burden reports. And so currently this is requires a manual step of a human create an ROI around the lesion area, and then we can generate these reports. So step one, we'll be able to enable a mostly automated approach where we'll be able to accept input images with hand-drawn ROIs and generate these reports. But with this multi-container architecture, we'll be able to deploy additional algorithms or models to actually automate some of those human steps in the future. So that's essentially it. I burned through that pretty quickly. If you have any questions, let me know. If you think of questions later, contact us. There's our general support email or phone number. Otherwise, I have time. We can dig into details for perhaps your specific use case or any other questions that you might have.
If you'd like to ask a question, feel free to either type it in the Q&A section of the Teams app, or if you'd prefer to ask it live, go ahead and click the raise hand, and try and get people linked in, as it were.
Josh, I have a question.
Yes.
You were discussing, so IB Clinic is fully automated, and if the information doesn't, if there's some kind of slowdown and the maps aren't generated, how would you manually override that? And are you training the techs, or are you training the radiologists to do that?
Right. Yes. Great question. So typically what we will deploy a workstation with our manual applications installed on that workstation. So as a backup, if IB Clinic is down, if the server is down, you're not getting output, we will have a manual workstation with our plugins, those Osirix plugins that Tim mentioned, in order to generate the output you need right away. And that's typically technician training. We'll train the technicians on how to use that.
Great, thank you. Okay, and one more question. When the maps are generated, they then, I'm guessing they appear then as a radiologist brings up a patient and does his dictation. These are all with each exam and can be retrieved repeatedly.
Right. Yes, exactly. So the output will have the patient's, study ID attached to them so that they will be organized and sorted into that same study as well. So if you can, I don't know if you can see this, but right here we have an individual patient with an individual study. We only had 3 input series, and then all the output was sorted and organized into the associated patient study in this case. Did that answer your question? Is that kind of what
Yes, no, that's great. Thank you. And so any referring physician or anybody else who wants results on the patient can then access these maps. Oncology can access these maps as well then.
Right, exactly. And they'll always be named, the output will be named consistently. So we'll have the map type with maybe some additional configuration parameters, such as a standardized RCBV. Grayscale won't have RGB attached to it. And then, of course, the color versions will have RGB appended to their series description.
Great. Thank you, Josh.
Thank you.
We'll give it a few more minutes to see if anybody else has some questions. Okay, I don't see further questions, and I know this was technical. For those that are, I know we had several people from some of our partner companies on this call, and we encourage questions in the future. If anybody would like more information and has questions, feel free to reach out to us. But we thank you very much for attending today's webinar, and please look look for future invites for future webinars. So thank you, Josh.
Thanks, Linda. Thank you, everybody. Yeah, you're welcome, guys. Thanks for joining. Yes, Linda, this is recorded, correct?
Yes, it is being recorded and it will be made available in the future on our Imaging Biometrics website. Under resources, you can find all of our past webinars, and this one will be uploaded as well.
Cool, thank you. This is the best part, hanging around for the emojis at the end.
Looks like most people have dropped off by now,
Yes.
but good job. Yeah. Hopefully this
Yep.
was very informational for people, and we get some good questions.
Definitely. All right. Thanks, everybody. I'll be taking off.
Yeah.
Bye.
Thanks, Josh. Bye.